In this course today we are going to discuss about the role of image processing in the mine automation system. So, this image processing system or image processing will be utilized in different mine autonomous system. So, we need to understand these technicalities of image processing that is relevant to the mine automation system. So, today I will discuss on those aspects that is very much relevant to the mine automation. So, in this preliminary stage, the things I will discuss today is basically subdivided into three components. Okay. Basically, what is image, that we will try to clarify in different with the different parameters that is associated with that. Second, in large scale mining operation, when we operates in mines like open pit mine or open pit mine field, so we many times utilize the image of satellite, remote sensing satellites. So, in this particular course we are also going to focus the image acquired by those satellites, and those images will be utilized in different times in the mine automation system. So, that requires some amount of informations as well as some amount of technical information for the students how to deal with those images. And in the last part today we will discuss about the use of a image processing system in a plant, mine plant. How in a mine plant, using the image processing system, I can automate my work and I can simplify my work efficiently, and I can enhance my productivity in the plant. Okay. So, these are the three things I will discuss today in this lecture in the image processing in the context of mine automation system. So, first we must know what is image, that is we need to understand. And in many times in the mine automation class, I tried to impress you with the things that many automation system basically inspired by the biological system. Okay. So, for example, the remote sensing system that we are going to utilize in the mine automation system is basically also inspired from our vision system very well these things to collaborate. For example, our human eye as a person, I am observing you, this wall, this chair, table, your face, through what? Without touching you, I am able to perceive, I am able to see you from a distance. How? It is because that in this room there are light sources are available. Okay. So, these light sources is available and these light sources fall on you, on the object, and from the object light is reflected and coming to my eye. So, in my eye, in the retina, I have cones, I have rods. So, in those system basically I able to get the information about you. Okay. Then through the nerve system, this is been sent to our brain central processing unit, and by that finally image, and by different training, learning throughout this age, I able to know you are Rohit. Okay. Like that. Okay. This is chair. Okay. Similarly, the remote sensing system is also inspired from this system. Okay. So, our eye is a very miniature of the remote sensing system, that is what we are dealing with today. So, in remote sensing system, we are going to acquire a large scale images about the mine field. For example, in our system we are going to assess the asset management system in the mine, for example. So, you know that in a mine there are number of machines, number of equipment are deployed, okay, in the whole mining leasehold area. Okay. So, monitoring of those equipment from the point of view of financial implication, that these are the things, there should not be any pilferage, there should not be any theft, and whether the equipment are in a real position or the equipment is moving, how to understand automatically using the help of remote sensing image. Okay. These are the things we are currently dealing with. So, there are different image processing system. From that we are going to detect the object, and from the object we are going to classify it is a dumper, it is a shovel, like that, it is a pump, like that. Okay. So, this is possible with the advent of different algorithms available, even with the open source programming technique. Okay. So, these are very much challenging field, emerging field. Mining engineers should know those things. And in the second part today, I will discuss a case study with you. That case study been implemented in a mines in Turkey, okay, for the autonomous system of detecting the quality of marble. Okay, that I will discuss today in detail. So, in these, slowly and slowly you will see there are different in different stages how image processing basically play an important role in your production chain process, and how this is been utilized, okay, in different point of time, in different aspect recognition. And in summary, I can say that these image processing nowadays is a very much important thing, very much low cost technology for you, and this is going to give you a edge compared to the conventional mining methods in totality of the economizing all the ways, okay, because all of the things you are doing remotely, and everything is visible to you in your database, in your window. From the center, from the tower of your headquarter, you can see all information about the mine, okay, movements of vehicle, movement of different equipments and their performance using the help of remote sensing image processing as well. Okay. So, these will be important for you to understand in the context of mine automation system. So, we will now discuss about the remote sensing image processing in the context of mine automation system. That I have already told you that remote sensing image and its processing going to play a game changer role in the mine automation system, particularly for the management of large mines. This technique is very much useful. There are two aspects in these things you have to remember, that is space-borne satellite system, that is remote sensing image, and also nowadays a low cost technology is available with you, that is the drone image. Okay. Basically our research group is actively working on that domain, on the remote sensing image acquired through the drone, okay, and those drone image are very high resolution image, and for different applications in the mining it can be used. Okay. So, in this context we have to understand that these images are basically captured under different prevailing circumstances. Okay. I hope you have an idea that our satellite system is in the space, and there are some cycle time, repeat time. Satellite captured the image about the mines, and from the satellite to the surface there are atmosphere. Okay. So, atmosphere is going to play an important role in your image in the context of the accuracy of the image. Okay. Because these remote sensing system that we are talking about is basically and mostly passive remote sensing system. So, you are acquiring the image from the satellite with the from the radiation of the earth's surface. This radiation is due to the sunlight. Okay. I am talking about the optical range. Okay. So, sunlight fall on the earth crust, some of the component is absorbed and some of the component is reflected. Those are the reflected, some of the reflected is in the atmosphere in its return travel scattered, and some component reach finally to the satellite sensor. So, the satellite sensor that is collecting the data about the earth crust have some amount of errors, that I hope you can understand. So, broadly these errors are classified into two categories. Okay. One is the geometric errors and the radiometric errors, and as an engineer we have to apply the correction factor, that is the geometric correction as well as the radiometric correction. Now, to apply the correction we need to understand some basic procedure, the basic principle. Okay. Basic principle is, you can understand that this satellite system, satellite is basically traveling. It is not, I am talking about the geosynchronous satellite. All satellites are not geosynchronous satellites. So, the satellite system, satellite is traveling. Okay. So, while the satellite is traveling, due to that travel and consequent image acquisition, obviously there would be some amount of geometric distortion in the image. What are the factors? These are the possible source of errors. Okay. Possible reasons of errors. Variation in altitude. Okay. So, variation in altitude means the satellite is not in constant height from the surface. Okay. So, due to that satellite is traveling, there is a field of view, you are acquiring the image, and if there is a slight change of height of the satellite, there is going to be affected on the geometry, because it is going to change the eye of a view, field of view. So, that basically finally contributes to some amount of error, that is variation due to the altitude. Second thing is that satellite is traveling, it is not with constant velocity. I hope you can understand, it is in a elliptical orbit. So, in elliptical orbit velocity is not always constant. So, due to the change in velocity, there would be some amount of error in the acquired image due to that change of velocity. So, these are the identified parameters I am talking about. Okay. So, you have to apply the correction factor. We all know that Earth is not a pure spheroidal structure. Okay. Basically, it is an ellipsoidal structure. So, I hope you know that its radius in the equator region is 6378 kilometer, something in the decimal, in the polar 6356 kilometer. Okay. So, it is slightly enlarged on the equator zone. Not only that, Earth curvature is not following exactly a kind of mathematical model. Okay. So, there are different mathematical model available with us. World Geodetic System 1984, popularly known as WGS 84. Basically, most of the GPS system we basically use that system for the Earth curvature. Nowadays, considering the geodetic surface of India, Indian government has planning a detailed geodetic survey, so that for the Indian continent we can get a better accuracy data considering the curvature in different land surface throughout the India. Okay. So, that also often leads to some amount of error that we have to apply correction. The next important factor is the relief displacement. This is very much important in the context of mining engineering as well, also in the hilly terrain, landslide prone areas, and also in the open pit area where there are large scale operation is going on. You know that in open pit mine, huge amount of OB is removed from the mine. Okay. That is also dumped, sometimes on the top external dump, sometimes in the excavated region, means decold area. Okay, you are dumping, but that dumping height is also huge, and when the dumping height is very high, we are also creating benches. Okay. So, 30 meter height each bench, there are some berm with 20 meter, 10 meters. So, there are steppy structures. Okay. And when you are collecting the image from the satellite, due to these variation in height in the surface, in the structure, there would be some amount of relief displacement error in the image, that we have to apply some amount of relief correction, because when satellite is collecting, it is a flat surface to the satellite, but actually we know there are height difference. Okay. So, we have to apply some correction, that is relief displacement. For it is very much relevant when we are going to reconstruct in the 3D for these whole dam structure. So, we have to consider those correction factor as well. The next correction factor that we are going to apply is basically the atmospheric correction, refraction. I already told you that there are two kind of refraction system that is going to play. One, amount of sunlight you are going to receive, and also when the sunlight is reflected back on the return track to the satellite sensor. Okay, as a gas, and gas there is a density difference, and due to that the light is going to refract in different direction, and due to that some amount of error is also going to be contributed. So, you have to apply some amount of correction. And the last but not the least is basically, you know that Earth is moving eastward. Okay. Satellite moving, but satellite is collecting data about the earth crust. So, in the meantime, satellite is collecting the data within a minute, within a second, earth have rotated some meter in that respect. Suppose there is a center, some meter, if you are collecting the data on the equator, the difference will be huge. If you on the lower side of the equator, error will be less. If you are upside of the equator, error will be less. Highest amount of error will be at the equator, because equator rotation would be huge in compared to the other part of this world. So satellite collecting the data, in the meantime earth is rotated, so there would be some amount of eastward rotation of the earth. Due to that, there would be skew distortion in the image. So that needs some correction factor to be applied. So these are basically the known sources of error that we can apply the correction using some mathematical model. Okay. There are in this context we are going to classify the geometric correction into two categories. One is the systematic and another is the random. Systematic error I have already discussed. We can very well know that these are the basically possible contributing parameter, that is contributing error, and we can nullify those error applying the mathematical principle, mathematical filters. Okay. There are some kind of unknown random distortion. We have not yet able to identify exactly those parameters. Okay. So this is the residual unknown systematic distortion. So these are very difficult to handle in that context. So you can only apply the correction if you have some known feature on the surface. So basically, as an engineer, we are basically dealing this kind of error by applying some ground control points, known features. Okay, and the reference of those ground control point is very much well demarcated and their relationship is well established. From that, I am going to remove those random errors, random distortion in the image. Okay. So these are basically, I am talking about all the image in the visible spectrum. Okay. Visible spectrum I told, because that is also very important, because you know that all these remote sensing image that I discussed right now is basically passive remote sensing and working. There is a interlinking medium is basically the electromagnetic wave. Okay, electromagnetic wave. So electromagnetic wave, you know that in an electromagnetic wave there is a two characteristics. One is the frequency, another is the wavelength. Okay. So frequency into wavelength is basically the velocity, and you know that velocity of electromagnetic wave is constant. Okay. So as the frequency varies, also the wavelength varies. So wavelength is basically varies in the range of 10 to the power 7 micrometer to the 10 to the power minus 5 micrometer. Okay, whole gamut of range. That is why there is a infinite in that context, infinite spectrum. Okay, so electromagnetic spectrum. That is why I told in the earlier slide that a visible spectrum, we are only concentrating on the 400 to 700 nanometer range. Okay, wavelength of that spectrum. This is basically the visible range. There are microwave range, near infrared range, and there are also the gamma range. Okay, so that basically we are not discussing today. Now the second kind of error that we often encounter in our system is basically the radiometric errors. Okay, it is obvious that this image acquisition is basically heavily relying on the sources of energy, illumination of the sun. So the illumination in different places, and for example in same place in different time, is also not same. Suppose the illumination in Dhanbad in the monsoon season, in the autumn season, in the spring, in other season is not the same. So in summer, for example, illumination is huge, compared to the winter. In the month of December, illumination is very less. So, this change of illumination is going to contribute the radiometric errors in the image when we are talking about data collected over the year. Okay. Even in the daytime also, suppose the illumination in 10 am, illumination at 3 pm is not the same. Okay. That also going to contribute some amount of error that we need to keep in mind, and we have to apply the correction. The second sources of error that may come is basically the atmospheric condition, haze, cloud. Basically, the optical range of image when we are talking about, it is heavily affected due to the haze and cloud. Okay. But if we talk about the gamma range spectrum, that is it is transparent, okay, to the cloud, haze, everything. Okay. So, that we are not talking about today. So, in our visible spectrum range, atmospheric conditions due to the heavy rainfall and heavy amount of cloud, it is very much affected. So, image will be blurred due to those kind of activities. Okay. Even in a heavy amount of fog, if there is presence, image is going to be affected. That we need to apply some amount of correction. Angle of view, okay, the angle of view at directly perpendicular, you are applying the you are basically collecting the image, or with some angle. This angle factor is also going to contribute some amount of error. Instrument response characteristics, this is very important, okay, in the context of remote sensing, because the life of sensors, and that is why in every time and in different time interval, we should basically recondition our sensor and standardize our sensor response system, so that we can understand easily what basically the response of the sensor under these given illumination conditions. So, sometimes due to these system error, system response characteristics, we are going to get some amount of vital information from the image, and these are basically going to contribute a huge. So, that is why sometimes these sensor need some replacement. Okay. And there is also some time that these satellite system can work for 10 years, 15 years like. Beyond that, you are not going to expect a good result from that satellite system. The next important point is the elevation of the sun. Okay. Elevation of the sun, you can understand that in the time of in the north globe, in the time of the summer. Okay. So, elevation angle in the winter in the north globe is not the same. So, due to that seasonal change sun angle, it is also going to contribute some amount of error. Earth sun variation, earth sun distance variation, our distance from the sun is around 1.5 into 10 to the power 8, I think, in meter. Okay. So, that is not constant. Okay. In the summer and in the winter, okay, that basically varies, and also these basically varies in the ellipsoidal orbit of the earth around the sun, also basically varies, and these distance are always not constant, and due to that we are going to get some amount of error in the image acquisition system in the visible spectrum. So, now we able to understand the different sources of or different possible error that may encounter in our acquired image, and these acquired image we are going to use for our own purpose in the mine automation system or mine automation monitoring system or some asset management system or mine monitoring, overall mine monitoring system. So, you need to apply some amount of correction factor. Okay. You need to enhance the image quality. Okay. So, there are two categories of image enhancement technique that is been usually prevalent in this digital image processing, because all the image that I am talking about today is basically the digital image. and digitally saved image. Okay. So, these are to be the enhancement of the image quality to be done in two ways. One is the point operation. Okay. So, we can change individual brightness of the pixel, okay, independently of the neighbors. Okay. So, that is basically the point correction. Another is the local correction. So, I am applying some amount of correction based on the pixel values, that is the brightness values of the nearby pixels. Okay. So, that is basically the local operations. Okay. So, these two are majorly in a broad category. I can say that these two amount of operation that we apply, and you know that MATLAB is one of the easiest tool for us in the academic community, because we have license, and there are also open source program available, Python, and there are so many modules available in the commercial regime as well. So, there are three kind of manipulation that we are going to do for the enhancement of the image. One is the contrast enhancement. This contrast enhancement is going to apply the gray thresholding, level slicing, contrast and stretching. So, there are few functions available in the MATLAB. I think that is IM adjust, and then the adapt something, check EQ, like that. So, there are some function usually used in the MATLAB. If you acquire the image, then apply that function, there will be some better image you are going to get in the output. Okay. So, there are some special feature manipulation also available, applying some special filtering and edge enhancement, Fourier analysis also been done. Then there are third category, the multi-image manipulation, that includes the multispectral band ratioing, differentiating, principal component analysis, canonical component analysis, vegetative component analysis, and decorrelation stretching and others. Okay. So, these are basically the possible method of image enhancement. So, there are in point operations two category we are going to apply, in that most image start with the low contrast. So, these can be improved using the level slicing, means reclassing the digital number. So, what is digital number? Digital number is nothing but the brightness value of the pixel. What is pixel? Pixel is basically, in image there are two kind of pixel in the row, pixel in the column, that basically represent the spatial characteristics about the surface. Okay. In the remote sensing regime I am talking about, and the brightness value is talking about the surface feature, surface brightness, about the different characteristics. It is a vegetation, it is a land, it is a roof surface, it is a road, like that. Okay. So, this DN number, digital number, is nothing but the brightness value. If it is an 8-bit image, so in the gray scale, gray regime, it is basically, it is 8-bit, means 0 to 255. Okay. And if it is 11-bit, the range will increase much. Okay. So, we basically, in level slicing, we basically differentiate, the difference can more easily be shown in the brightness. If we change the brightness value, different value can be assigned based on the requirement, and these basically the level slicing. Contrast stretching, suppose in 8-bit image, whole spectrum, whole width has not been used. Okay. So, from 0 to 255, so total bandwidth, if it is not used, I am stretching. So, basically a smaller number of value has to be changed over the whole DN range. So, by that I am going to get a better quality image, that is contrast stretching. This is one of the example. This is the digital number of different histogram of the same image. So, note that none of the cases the digital number is not 0. So, these data is been found out from this tutorial of the crispneos.edu.sg. You can find out this case study very well. From there also, in the left side image, you see the image is blurred due to the hazy atmosphere, and there are heavy amount of scattering as well. Using the gray level thresholding, we have got a improved image on the right side. Okay. So, basically these tools are basically showing that applying these corrections I am going to get a better quality image, and that is very much useful in the context of the mining as well. So, the next level is important on in the processing of the image is basically the spatial feature enhancement. Okay. So, neighborhood operations that calculate the new values of the center pixel based on the value of the neighbor. Okay. So, suppose for the example we are basically dealing in the mines. Basically sometimes we found that some of the component is basically missing, okay, in the road, and I can very well understand the point missing is basically the haul road, okay, and I know the brightness value of other points in the haul road. So, I am basically applying that amount of value to that pixel, and I am filling that particular area. Okay. So, basically it is basically the spatial filtering based on the newer values of the DN number. I am going to apply on that particular area those DN number values. Okay. That is in the next phase is the edge enhancement. Edge enhancement is very much required, particularly in the image, particularly in the mine leasehold area boundary estimation. Okay. There are, when you are basically submitting the file to the ministry or some approval, your edge should be defined clearly. No ambiguity should be there with the other party, because beyond boundary there are some other organizations. So, there should not be any dispute. So, edge is very well should be demarcated in your image. Okay. So, sometimes due to all these error, edge sometimes some amount of error is there. So, first of all we must apply some amount of correction technique. By that I am going to get a clear cut edge. Okay. This is also very much relevant for the automatic feature detection in urban planning as well. Building edge, whether that building is within the leasehold area of that owner of the building, or it is basically encroaching other boundary, or the road detection edge, road is within the within that particular organization, or it is basically encroaching other area of that other owners. So, edge enhancement is very important in that aspect, and there are few classification technique as well that we need to understand in the context of image processing. That is the spectral pattern recognition, that is basically the pixel based on its pattern of radiance measurement in each band, more common and it is very much in use. And the spatial pattern recognition classify the pixel based on its relationship to the surrounding pixel, more complex and difficult to implement. And temporal pattern recognition look at change and pixel over time to assist the feature recognition. Okay. So, there are two kind of method for classification. One is the supervised, based on the known features. You are basically training that these are basically these basically the road, these basically the building, these basically the vegetations. So, you already know and you are providing some amount of ground control points and ground control characteristics. So, based on that you are going to supervise the spectral classification. Unsupervised is without any help with the trainer, so called trainer. So, automatically based on that radiance factor, radiance value, it is going to differentiate different class. Okay. So, this is basically the example based on the different values of the spectral classes. It has automatically classified. So, these basically representing 2-3 different kind of class. So, these basically overall the uses of remote sensing in the context of the mine automations. Now, I am going to tell you and share you with an interesting case study that going to utilize the image processing as an automated system in the industrial conveyor belt for the classifying of marble slabs. Okay. So, the name of the case study is an automated industrial conveyor belt system using image processing and hierarchical clustering for classifying marble slabs. Okay. This case study is from Turkey. It is published in one of the famous technical journal. So, here the task of the system was set up in this way, that you know that marble quality in marble mines, quality of marbles is defined by few characteristics, okay, and based on that quality and characteristics the price of the marble varies, okay. So, in this case study things are being enumerated, that using the help of image processing I am going to classify broadly the marble into different category, and I can do it automatically. So, that basically the advantage of this system being discussed here. So, here we are using only one kind of sensor, that is the camera, okay, normal camera, as well as web camera or CCD camera can also be used in this system. And here we have set up a small case data acquisition system, okay, and that acquisition system is set up over the conveyor belt in some suitable location, and so that I can measure, applying some amount of light, the image of the marble that is going through that conveyor belt, okay. So, it is also an electromagnetic wave, that is a light wave we have used, and the camera sensor placed top over the conveyor, so that I can get the image orthographically, okay. So, we have collected a number of data to process those features present in the marble, and then we apply the classification factor of the item based on the extracted features and the classifier, and then the last is basically performing the necessary action following the classification of the result. So, different classes of marble been identified, so that we can dump in different stack geared classified for those marbles. So, that is what is the basic basically the basic information on which I am relying. Basically, marble have different physical and mechanical characteristics, and that can be classified universally based on that categories. And you know that colors, different color spectrum, pattern in the marble, basically it increase the aesthetic of the marble quality, and different kind of texture also going to give a better basically the better feature about the marble and also the price, okay. And these are basically very much important, because in the remote sensing image classification and analysis, I tried to forget that when there is a geological fault, okay, the spectral frequency will be the highest, okay. So, compared to the other pixel present in nearby, it would be the highest. So, from that high frequency spectral frequency, you can easily identify that this is geological fault. Similarly, in the marble, if there is a pattern, you are going to get a higher frequency, okay, spectral on the image. So, you can easily identify that spectral using the classification method, object identification method. So, this marble is been collected from the Manisa region of Turkey, okay. So, the case study that we are going to discuss today is not an universal kind of things. Based on different mine marble characteristics, we have to set up this experiment and set up the whole setup, and because the different color scheme, different heterogeneity scheme is basically different in different mine site present in throughout the globe. So, this is basically a case specific system being fabricated, and here marble is been classified using the color scheme, homogeneity scheme, size, orientation, thickness and distribution of the field joint. Okay. Field joint means, you know, if there are huge amount of field joints, and then that is not going to be attractive marble in that context. So if there is a vein structures, so that is not good in the market. Basically these characteristics means classification generally been done in the mines by an human expert. Okay. So mines to mine, the different expert is there, so they do their task. So this system is going to replace that human system. Okay. So in that context it is lucrative to the mine owners. So these are few image. You see that on the left side A is basically the group 1 quality marble. Hardly there is any feature. Okay. It is a there is no spectral feature, no feature basically. Group 2, there are some veins, some vein structure present. B. Group 3, veins are there, are also some amount of filling material is there, and on the D, full of filling materials. Okay. Okay. So it is also not having good amount of features. So first one is the homogeneous limestone A. Okay. B is the limestone with thin joint, fill joints, and C is basically the brecciated limestone, composed of limestone grain of different shape and size, cemented with cohesive matrix. So cohesive matrix is used here on the C side, and on the D is basically full of cohesive matrix. Okay. So cohesive matrix is defined as the collection of joint veins that are unified to construct a larger area of the material. Okay. So this is basically some, due to some discontinuity, this basically been created. This is the setup that we are going to discuss today. This is basically the setup. You see that is, this is basically the image processing part. Okay. So here the camera is set. Okay. The inside of the camera is been shown on the bottom figure. Camera just put on top so that it can acquire the image perpendicularly over the marble, and you see on the box that is been set up as a image acquisition setup. Throughout the box there is a fluorescent lamp all through, so that shade effect we are going to remove. Okay. And also the brightness of this fluorescent lamp is been so set that we are going to avoid the burning of the image. Okay. If there is huge amount of light on a particular point, image will be burnt. Okay. So that we are going to avoid. And there is a conveyor system, and the conveyor system is fitted with the pneumatic piston, and pneumatic piston is also been connected with the PC, and the PC is also connected with the controller, and this image acquisition system is also connected with the PC. Okay. So it is a closed loop system, and in this closed loop system, camera getting the image of the marble one after another, and based on that, once the acquisition is done, it is on the computer, a command is gone to the control system that now move another marble to the box. Okay. So again the movement of the conveyor belt is initiated, then again stop, camera take the image. Okay. Then again it will give the command to the computer, and computer to the control system to the pneumatic piston, again move. So side by side continuously this image acquisition is going to take place. So this is basically the block diagram of electromechanical conveyor belt system with the marble classification. And you see on the right side there are stack, basically a inclined platform that basically load the marble on the conveyor belt. Okay. And also there is some basically some arrangement for loading the marble as well as to take the marble from the conveyor belt as well. Okay. So, this is the closed loop onto the inside of the data acquisition system. You see that we are basically designed the camera in such a way that there is no shade effect. Okay. And also the fluorescent light intensity is such that all through in the wall, so that a uniform light system is been achieved on the whole image system. Okay. And the camera specification is this: 8 megapixel Canon EOS 350D digital camera with 18 to 55 mm EFS zoom lens, or we can use the CCD webcam as well. Okay. So, this camera is fitted with the USB cable to the computer. There is a light source, also the lighting condition is also under control of the whole setup. Desktop computer is fitted in the system, and also cabinet housing all these parts. Okay. So, this is basically a very small system that is fitted. You see in this, it is a very small system, and this 8 megapixel camera is going to produce a resolution in the range of 1575 into 1550. Okay. So, these are the pixel row and column. So, experiment based on the analysis, we found that 315 into 3110 resolution image is sufficient for the classification of the image that we are basically discussing. So, in that context it is a redundant information, because we can go for a low quality camera as well. We can reduce the price of the whole system by that. So, camera position should be perfectly perpendicular, and the cabinet is connected through USB cable to the desktop computer and computer through the controller. And we have tried to ensure the uniformity of the light, I have already told you, and system is fully isolated, and each and every marble is acquired the image only when the conveyor is stopped, image is taken, again it's moved, conveyor stopped, image taken, again moves, like that. So, fluorescent bulb is so positioned that there is no blazing. Okay. And also we are trying to position the fluorescent bulb's angle so that there is no shade effect. Okay. And also we have tried to paint the wall of the cabinet with a black, so that there is no scattering of the light, okay, from the wall. Another things that even after all these care, there is a possibility that there are some amount of non-uniformity in the light source or illumination. So, what we have done, we have applied some correction factor. We have taken an image of a white paper through the green channel of the window of the camera image, or in the RGB scale, and that basically we have applied on the on the image, and this is basically the source. So, green channel image of the white paper is auto corrected, and finally we are getting, this is the corrected image. Okay. Acquired image on the A. B is the correction non-uniform illumination by adding a template image obtained from the white paper to the green channel of the acquired image. Then I am getting a revised image of the same of C using the grayscale imaging technique and background cropping. This is a corrected image. So, after applying the different corrections, a final image is been acquired, and we are going to classify different synthetic images using these kind of categories. Okay. A is a typical sample of the group 1 category. Cohesive material in the region is very small. In the 2B, there is a vein structure is present with the cohesive material. On the 3rd, there is a good amount of cohesive material is present in a unified region, and D is a full of cohesive material. Okay. So, out of the whole setup, total sample of 1158, 172 of the group 1, 388 of the group 2, 411 of the group 3, and 187 of the group 4 image has been acquired and classified using this system. Okay. So, all these things done without the interference of an human being. Okay. So, this is basically the logic, hierarchical logic in the program that has been set in the computer, and computer basically total finally classified the image into different category, and this is basically the result we have seen. So, this is the whole setup, whole mechanical setup. The image A basically showing the mechanical structure for the pistons and the loading frame, and the B basically the pneumatic pistons, C is basically the PLC that is being used here in the SCADA system, D is the rear circuit, rear relay circuit, E is the 220 volt panel, and EF is the basically the air compressor for the pneumatic piston that basically drives the whole system. So, this is basically the flow chart of the complete system. Initially start, wait for the marble, whether marble is there, yes, then it basically image is acquired, and else it will go on like that. There is a logic. So, this is basically the final figure of the SCADA framework. So, now we have merged the acquired image system through the cabinet connected to the computer, computer connected with the control system connected with the piston is connected to the pneumatic system. Okay. So, whole system is operate under a single control, and here is a MATLAB GUI of the system. So, here SCADA framework is integrated in the image processing system for quality assessment and classification of the marbles as well. So, in summary, we have discussed the two aspects of the image processing. One is for the remote sensing image, its processing in the context of the mine automation, and a normal camera image acquired in a plant, how it is being used for classifying different objects. Okay. So, these are very much used. So, the usefulness of the whole system is for the plant system that we have talked about, the image acquisition camera, it is a very low cost system, I think less than 10-15,000 for the whole cabinet system, and associated with the computer, if you add that cost, it is going to give you a complete automation system for classification of the marble. Okay. So, that is going to give you the service for few years, 3, 4, 5, 6 years. Okay, until sensor are not working. Okay. So, that is going to replace the expert human being in the systems. So, image processing as a whole is nowadays a very much welcome step in the mining industry, and particularly in the mine automation context, and there are different other applications as well. We will discuss if time is available. We are basically also working for the slope stability of the mines using the drone image and its processing, and how different in time sequence with that image we are going to assess the stability of the mine dump through that image. Okay. So, there are multiple applications possible in this context applying these processing technique. Thank you very much.